all have similar needs. There's common patterns that come up again and again and again. And one of those is, of course, service discovery. We just talked about circuit breaker. There's routing. There's client-side load balancing. And it should also be pretty clear that there's companies that have a lot of experience in this, like, say, Netflix. Now, there's also a company that's built a bunch of open source components around this space, and that, of course, would be Netflix. The beauty of this, like so many things that we've talked about today, is you add in a couple of annotations, and now you have access to all of this amazing open source stuff. So one of the things that we have here is Eureka. So it should be clear that service discovery is a pretty important part of distributed applications. As much as we'd like to think we always know what's going to happen, we don't. You know, I certainly remember building applications where we knew this is where that thing lives, and for all practical purposes, you had hard-coded that location into your system. You can't do that anymore because services come, services go, they get scaled up, they get scaled down. They're not on the same piece of compute the second, third, fourth time you call them. You cannot manage this all by hand. I'm sorry, that way lies madness. Now, there's two pieces of this equation. There's the Eureka server and the Eureka client. The server absolutely can be configured to be high availability, and the default here is to actually run multiple instances and then peer them together. Now, this can also be run standalone if that's more your cup of tea. What you do is the clients are ultimately going to register with Eureka, and you provide common information. Port, this is where I'm running, here's where my health check lives, etc. You put the Eureka client starter on your class path. The apps, as they come up, auto-register. Now, Eureka is going to get a regular heartbeat from those service instances. Unsurprisingly, if the heartbeat fails, it's going to remove it from the registry because there's no point in even calling it at that stage. This is going to use those default info and health actuator endpoints we talked about earlier. See how this builds upon itself. And of course, this can all be configured to be secure. Now, out of the box, it can take up to 3 heartbeats to get everyone on the same page, but you certainly can shorten that if that is what you need for your situation. You then use Eureka Client to actually find those service instances. So again, you don't have to know where it is. This gives you sort of this alias you can use to then say, you know, go get me the print service, go get me the new customer service, whatever it happens to be. Now, there are alternative clients as well if that you. And you're going to run in multiple zones. So you can actually configure it so that it will stay in the same zone to call those services so you don't add extra latency when you don't need it. Turns out that speed of light constraint is a real thing. Now, we don't just need service discovery. We need things like Ribbon to do client-side load balancing. You can use that with or without Eureka. Your call, same exact approach. You add the starter. Who could have seen that coming? And then we configure that via boot configuration files. There are default configurations that you can create as well, and of course that can all be customized based on your current environment. You do have the ability to directly access Ribbon if you want. Out of the box, that's done as lazy loaded on first request, although you can always set it to load eagerly if you prefer. All right, so that is the deal here. Now, I believe we have a demo of this, so let me silence myself, get rid of
me. Can you see my screen? Just double checking.
Yes, and yes.
Cool. All right. As Nate mentioned, if I want to use Eureka, for instance, as service discovery and Eureka client, of course, I need to add the dependency like Eureka discovery client, which I did. And let's go back to our application. Our oops, that's my desktop. I'm embarrassed right now. To our credit card application without the circuit breaker. As you can see, we have failing risk client, we have /evaluate, we just call the failing risk client, and soon we are going to replace this failing risk client with an actual actual survey that I will run on my machine, which means we'll have 2 separate processes, 2 separate services, 2 separate, I would call them Spring Boot applications to be more precise, talking to each other via HTTP, and they will connect using service discovery. So from the credit card application, the one that we are looking at right now, we'll talk to the different application called risk with evaluation controller with /evaluate endpoint as well. But this one just returns OK from a real external separate remote app. All right. But to achieve that, by the way, I mentioned that I added Spring Cloud Starter Netflix Eureka client to my class path. What I can do as well is to add annotation called enable discovery client. By the way, this is just a read only, or not read only, but just a friendly reminder annotation. So without this annotation, Spring Boot also picks up this dependency and do the same stuff which it does when I add this annotation. So just a friendly reminder for our colleagues that this application in its main class uses discovery client. All right. So maybe first let me try to register the application in a standalone Eureka server. But the question is, where do I get the standalone Eureka server from? So I will use Spring CLI, which is a nice tool, command line tool built by the Spring team, where I can just start Eureka server on my machine. As you can see, Spring Cloud Eureka is a Spring Boot, guess what, Spring Boot based application, which will run with an embedded container on some specific port, which I always forget, 8761. I can go to this dashboard. As you can see, I have no application registered. That's expected because we haven't started anything yet. Let me fix that. I will run the application, the first application, and what it does, it will try to register to Spring Eureka, to Eureka server, using default port, which is 8761, and default URL, which is localhost. So, of course, on production, I will have to change that, but for the sake of the demo, the defaults are enough for me, because I'm running on my local machine, actually on the port 8761 or something like that, an instance of Eureka server. So now, if I run this application, it will try to register with a name called credit card to this running instance of Eureka. So let me try to do that. Rerun the application, and see what happens. By the way, in the meantime, maybe let's wait until it registered. By the way, it runs on 8888, the port 8888. I have discovery client, credit card, registration service status 204 registered. Let me go and see. Let's refresh that. As you can see, I have two applications registered because I haven't I forgot to disable the risk application. It's already running. The risk application. That's the second application that I wanted to run. We talked about this like 5 minutes ago. The one which returns OK from the real app. So this is already running. You know what? Let me run this application one more time. But to do that, I will need to change the port, because otherwise I will have a port clash. So let me run this application not on 8777, but let's say 8776. And now I will run this application, which means I will have two physical instances of risk application running in parallel on two different ports. That one on 776, the previous one 777. I have one logical application restored under the same name, as you can see, with two different addresses, two different physical addresses, one logical name. And now, what we are trying to do, we'll try to connect from credit card to risk application, or to be more precise, to one of the instances of risk application to evaluate risk when someone applies for a credit card. All right. Let me go back to the first application, credit card application. And now, instead of calling the failing risk client from the previous demo, I will create a new class. It will be a client that will call the second application that is actually running on my machine. But I don't want to reinvent the wheel when every now and then when I want to cause external app, which logical name I know. I have no idea what's the port of that application, right? And what's the IP and so on. I have no idea, but I know who I'm going to call, but I don't know their number. The same like with contact app, right? So Spring comes with Rescue, and there is a small project called Feign, which I can leverage to overcome that problem. With Feign, I am able to write just an interface, risk client. That's the name that I just picked up. But what I need to do is to use an annotation called Feign client with the logical name. So what I need to know is the logical name. And I also need to know the endpoint, like /evaluate, because the second application, let's take a closer look, exposes /evaluate. All right. So what I need to know, what I need to pass is that information to my calling application. At request mapping, the method is get, and the path is /evaluate, right? All right. And this returns string, let's say, evaluate. Okay, so now I'm able to use this risk client instead of failing risk client here, like this, risk client. And the application, the credit card application, when I hit /evaluate on 8888, it should go to Eureka and say, hey, I want to talk to risk client, where's risk? And it will give me instances of risk under the hood. And one of the instances will be called. Which one we are going to talk about soon, but let's first try to run it. One more thing I need to do, I need to teach Spring that I'm actually using the @Feign client annotation. So there are clients which I'm going to talk to, there are applications which I'm going to talk to via Feign. In order to do so, I need to enable Feign client, and Spring will scan the application, look for annotations like the previous one. Oh, what happened here? I don't want this. I want this. I want that. All right. All right. We'll scan and see those interfaces and create a Spring managed beans. All right. So let me rerun the credit card application. What we are trying to do right now is to hit /evaluate and see the answer coming from this application. So, okay, from the real app. Let's see if we are able to do that. Curl, what was the port? 8888. Curl, localhost 8888 /evaluate. Yeah, so we are calling the second app, as you can see. So actually, 3 pieces of infrastructure are involved in this communication. Credit card application, risk application, and the service discovery. Which one is picked? That's the question. So this is what brings us to the point of client-side load balancing. Nate mentioned Ribbon. Ribbon is implementation of client-side load balancing. You have multiple different algorithms to load balance on the client side, so it means on the credit card side, which application we are going to choose. You can implement your own algorithm to route between different physical instances, or you could pick something which is already given. For instance, I can pick and register a bin. iRule is the implementation of the algorithm, is the interface for the algorithm of your choice. And you have multiple implementations. For instance, random rule, why not? Very useful. You have different things like round robin or zone avoidance. And of course, you can implement your own one. All right. And now, having registered that bin, that gives our application information which load balancing algorithm I want to choose. Let me rerun this application, the credit card application. You know what? Maybe we'll even debug it. And I will have a breakpoint somewhere in here in the random rule, so that we'll see when I do curl and we go to Eureka and get 2 instances, and then we load balance, we'll actually be static in here, hopefully. Terminal, clear. Yes, we are here, as you can see. Let me go down, step over. Maybe let's go here to all of the reachable servers. I expect the size of that list to be close to 2, yes. I have 2 instances, as you can see, 776, 777, 777, and actually around random rule, as the name suggests, picks one at random. That's the code for that. Let me finish this. And yeah, we got the answer. All right. I think that's it. We covered Spring Cloud Eureka running on this machine with dashboard. 2 instances registered with a specific name, credit card and risk. Risk was physically deployed twice under using 2 different ports. And we are also able to connect from credit card application to risk, without having to know the addresses. But I know the addresses of Eureka, so we are able to connect from credit card to risk. The question is, what happens if Eureka is down? So Nate mentioned that I can have a cluster of Eurekas, of course, that's preferable. But also, what I can do is that if the communication is very frequent, most probably I won't have that many topology changes. Credit card application can cache the information about, hey, where is risk, where I can access risk, so that we don't have that many calls to the Eureka server. All right, that's it. I'm going to hand it over to my friend Nate.
What do you mean by event-driven? This is one of those, it's in the eye of the beholder. It depends on who you ask. Martin wrote a great piece a few years back talking about what they mean by event-driven, and it was basically based off a discussion that they had internally, and some of their people loved event-driven architecture, some hated it, and eventually they figured out we're talking about different things. So it's possible this is a little bit of in the eye of the beholder, but I like to look at it in terms of we have different patterns here. So which of these eventing patterns are you using on your application? What's a good fit for you? So there's event notification. In other words, a thing happens and the source system just shouts out into the void, this thing happened. So a new customer signed up. We just got a new order. This thing shipped, whatever it happens to be. It's the embodiment of bang on the cowbell because something happened. The emitter of the event does not care or know what happens after it says the event happened. That's all downstream at that point. This is a highly asynchronous model, and it is an example of what I referred to earlier as the zeroth law of computer science, high cohesion, low coupling. So that's a big win here. But as we all know, after being in this business for more than a few minutes, everything is about trade-offs. There's always downsides to these approaches as well. One of the biggest challenges with this kind of a system is, do we really understand what happens when a new customer signs up? Do we really understand what happens when an order is placed? It depends on who has registered or potentially deregistered interest in that event happening. These systems can be very challenging to debug, and it can be really hard to reason about the system. We already talked about monitoring. It is vital to these kind of systems. You absolutely have to have your observability story straight, or you will, that way lies dragons. Very easy to lose sight of the actual flow of the application and what happens when a new customer signs up, what happens when an order is placed, what happens when an order is shipped. Now, there's another variant of this called event carried state transfer. Now, it's the same basic idea. Event happens, event gets emitted, but the event itself includes additional details about the event. In other words, the customer went in and updated their address, so we emit the customer updated address event along with the new address and maybe the old address if that's necessary as well. Advantage of this is subscribers don't have to turn around and ask the emitting system, hey, what would you say the change was again? This is an example of ask or tell, don't ask. This is what we try to do in sort of OO Programming 101, yet another thing that Martin has written about, tell, don't ask. Big advantage here is reduced latency, because the event already includes the information that the source system or that the consuming system might actually ask of the source system, and it also prevents the source system from being overloaded by a whole bunch of requests for tell me more, please. So if you think about the way some of these systems can work, there could be dozens, hundreds, thousands of consumers that have registered interest in the address updated event. Every one of them is going to have to call back to the source system if we don't carry along that state. Now, there's downsides of this. Again, everything in software is a trade-off. I was actually having this conversation with my son earlier today. I said to him that so many things in life, there is no best answer. There's just a least worst answer. And I know that kind of sucks, but that's just the nature of the beast. Software is not immune from that. So many of the decisions that we're making as architects, designers, developers, as well, what's the least worst way to do this? So what is the downside of this event carried approach? A whole lot of data gets tossed around. Potentially, ample amounts of data. Now, honestly, this is probably less of an issue today, although latency is a real problem here. If these systems are very far apart and I'm sending a lot of data down the wire, we get the proverbial buffering out of that. It also means receivers have to know what to do with whatever the event is carrying along with it. That takes us to event sourcing. This is probably what most people think of when we talk about event-driven, but it's not universal. The idea of event sourcing is you record every single state change. And unlike the way we've typically done this, the event store itself becomes the source of truth. When I think back to so many of the applications I've written, the database was the source of truth. And that was the most important thing. I worked on a system for a long time where we had a very stringent audit requirement. So every change to the system had to be audited out. So we had separate audit tables for basically every one of our main tables. We had a whole separate system that one of my amazing developers wrote to sort of automate that, so that when you created something, you didn't have to build all the audit stuff in. It was just there as kind of this little mini framework thing she created for us. So moral of the story, we needed to know who made the change, when they made the change, what the old value was, what the new value was, etc. That really was an event store. We just didn't know it. That hadn't been invented at the time. But we really would have benefited from an event store. If the event store is the source of truth, a database that gets generated out of that is really just a snapshot in time. It's a projection of the data. It's a different way of thinking about databases in particular. This is generally where someone says, ooh, Kafka. Yes, I want Kafka on my resume. I'm putting Kafka in my system. If you want to know more about Kafka, you can go talk to my good friend Tim. He'll hook you up. This gives you very strong audit log, and it makes it much simpler to recreate history than we had to do more years ago than I care to admit. Makes it a lot more straightforward to run hypotheticals. What would happen if this happened? What would happen if that happened? Of course, evolving your schema is a pain here. Schema is where a lot of good ideas go to perish. I do think the pain of changing schema is at least part of why so many people sort of generated towards some of these non-SQL databases and things like document stores and things of that nature. It's also a little challenging to replay some of these things when you have to interact with outside services or outside systems, because they may or may not actually be designed for you to do that. A related pattern is CQRS, Command Query Responsibility Segregation. Again, Martin has written about that. This is actually fairly common in applications to have a different data structure that you use for reads than you use for writes. Writes typically have a different sort of cadence, a different sort of burstiness that's different for reads, or a schema that you want for writes is more efficient, but then it makes it bad for reads, vice versa. So you separate those two things apart. Of course, the challenge there is you have to keep your read data updated on some cadence. You can get stale data, so you need to understand what that latency is, what that means for you. Sometimes it's a daily thing, sometimes it's every few seconds thing. So you do get some pain in keeping that alternative data structure in sync with the primary data source. Now, I would argue this isn't really event-driven, but it's often used with event-driven. So that's why I bring it up in this context. Now, don't just take my word for it. Martin has a great piece where he gets into much more depth on this, and certainly we've written about this as well. Now, that, of course, leads to a natural question. Which of these I can give you is it depends. It depends. It depends on the needs of your system, what the trade-offs are for you. I remember a few years back having a conversation with one of our clients. They had transitioned their application to an event-driven style, and I honestly don't know which one. They didn't give me that level of detail. But this particular person I was talking to is just sort of saying, yeah, I really regret it. We shouldn't have done it. It's more complicated than it needs to be. We're not getting the benefit we wanted out of it. So it's possible that they meant one style of event-driven and they really could have used a different one, or maybe it just was a bad idea in its entirety and they never should have gone down that path. It's all about trade-offs, friends. Now, this is also where, and I put on my cloud architect hat, somebody usually says, hey, Nate, how do I do distributed transactions in cloud? Well, my answer to this is actually really simple. You don't. You don't do distributed transactions in the cloud. And this is usually where they go, whoa, hang on, Herring. I got to do that. I've got XA in my system right now. I have to have distributed transactions. What are you, crazy? And I say, well, let's be real blunt here. Where do you do that in the real world? I mean, you don't. So I think about this Zoom world that we've been living in. A lot of us really haven't paid a whole lot of attention to what we wear sort of below the waist. So maybe you go and buy a brand new shirt so you look a little spiffy on your Zoom call. And wherever you buy the shirt from, whether it's online, whether it's brick and mortars, they have a return policy of some sort. You bring the shirt back within 30 days unused or something. Well, here's the thing. When you buy the shirt, it's not like they keep that transaction open for 30 days. Of course not. The sale is committed. It's taken out of inventory. You are charged. That goes into their P&L sheet. If you bring the shirt back a week later, what ends up happening is a series of compensating transactions. They update their inventory to say, we have another instance of this shirt. They issue you your money back in some way, shape, or form. That's exactly what we do in the cloud environment. We have to issue a set of compensating transactions to roll back what happened before. All right, so what does this have to do with Spring? How can Spring make life easier for me? This is where Spring Cloud Stream comes into the equation. Now, here's the thing. As an architect, I want flexibility. I want to be able to adapt to change because that's the one thing I feel very confident is going to happen in my lifetime. Things are going to change. Now, that does present us a bit of a conundrum. I've been told that architecture is, the decisions that are hard to change later, the decisions we wish we'd gotten right in the first place. But hang on a second here. I know things are going to change. Perplexing. So as I said earlier, I don't ever want to paint myself into a corner. I don't want to ever to be sitting there going, I don't have any other options. Luckily for us, Spring Cloud Stream allows us to swap out the broker as necessary. So we can use what's right for our teams and change that if our needs change. It supports exactly what you would expect. Rabbit, Kafka, Kinesis. There's a whole bunch of partner maintained bits, including the cloud-specific instances of some of these event brokers. What we end up getting here is a binder to the external broker, and it's all middleware neutral, right? We don't care who you're actually using under the covers. We'll abstract that part away for you. There's also a test binder you can use for integration testing, and of course, if we don't support something you need, you can always build your own binder. It's that destination binder that's ultimately connecting you to your messaging system, and that's where all that boilerplate configuration stuff lives. That is the bridge between your application and the actual underlying broker you're using. You build an application that then just consumes and produces messages. That's it. There are binder-specific health indicators that come out of that, plus a whole lot more. All right, I am going to pause here, and we're going to let...
So remember that every time we're doing that training, I would say, one day I have to update the Spring Cloud Stream demo.
Yes, I do recall that. You did?
Right. Yes, I updated the demo.
Did you do that earlier today, or did you do it while we were talking tonight? Because that's always the fun part, is when do you update the demo?
To be fair and honest, completely honest, both. Like, I found some time late back in the day, but now I was fixing at 3:45 a.m. So that's gonna be fun. It's gonna be fun.
Oh yeah, let's do it live. What could possibly go wrong?
Yeah. So Nate mentioned Stream Cloud Stream. It's a framework for building highly scalable event-driven services, microservices, Spring Boot applications that want to be connected with each other with a shared messaging system that you can swap. And we support different binders, Kinesis, Kafka, Rabbit, PubSub, or whatever you would like to build, maybe your own. You will see in a while that framework provides, I would say, kind of flexible programming model, and it uses also already quite established patterns which are familiar for Spring users, for Spring integration users, and already established best practices. All right, so what I need to do in order to tell my Spring Boot application that I want to stream, guess what? I need to add a dependency to stream, like this Spring Cloud Messaging framework for building highly scalable event-driven microservices. Binders, Kafka, RabbitMQ, PubSub, etc. All right, but that's not enough, because that's only specifying that I want to stream. Where do I want to stream to, or where do I want to stream from? Like, what's the middleware? Nate said that Spring Cloud is middleware neutral. Yes, it is. But anyway, anytime I want to use messaging, I need to actually connect to a specific broker. So that means I need to pick something like Rabbit, for instance. And then if I explore this POM XML, you will see two different dependencies, which are very important. Spring Cloud Stream, which means, hey, this person wants to use streaming. And also the second dependency, Spring Cloud Stream Binder Rabbit, not Kafka, but Rabbit, which means this person wants to bind the streaming platform to Rabbit infrastructure. So the streaming abstraction, not platform, to Rabbit infrastructure. So thanks to those two dependencies, the only sane conclusion that can be drawn out of this is, hey, I'm going to try to connect to RabbitMQ using defaults, as well as with different examples we have seen today. You can change the defaults, of course. But if I don't do it, and if I run RabbitMQ in my Docker container right now, on a default port, which is 5672, Spring will try to connect to localhost 56672. And that is how I won't need to change anything when it comes to properties, because I will be using the defaults. Of course, on production and in cloud, there is no localhost. All right, so I did that, and I have two applications. The first one is called Source. As you can guess, it will be the supplier of information. It will be sending the events to, or any piece of information to RabbitMQ's exchange, and I have those two dependencies as well. And I have sync application with the same dependencies, RabbitMQ, because we want to talk to each other, and Spring Cloud Stream. And the second one is called sync. That will be a consumer of the RabbitMQ's exchange. And where do I specify the RabbitMQ's exchange or Kafka's topic? Because I can have, remember, different brokers. To do that, I need to go to application.properties, and that's the name of the channel that I'm talking to. Sorry, I'm listening from. That's the group ID that I'm connecting as a participant in the streaming platform to this channel, and that's the actual thing in RabbitMQ or in Kafka. So in RabbitMQ's case, it would be an exchange. In Kafka's case, it would be a topic, right? But we have RabbitMQ. So when I start those two applications, by the way, the second application has one output channel called output, again with a group ID, but they connect to the same RabbitMQ exchange. That's why they will be able to connect. So this is it, but how we are actually, what we are doing with the events at the consumer side and how we are sending them at the side of the source, the application that is the supplier of the information. So let's start with the former, with the sync. So with the one which connects as with input channel to the exchange of RabbitMQ called events. So with the new API, the functional API of Spring Cloud Stream, the only thing that I need to do is to register a bin. Register a bin, which is the function, by the way, hence the name functional API. And the function will be consumer, because guess what? I'm a consumer, let's say, of strings, right? And the name of the channel that I want to listen to is sync, as stated in here. And what we are going to do, I can register lambda, for instance. Maybe let's just print it like this. All right. So this is enough for Spring Cloud Stream to understand that this handler, this consumer, will be registered for this exchange. So whenever something comes in this RabbitMQ's exchange or Kafka's topic, because if I change it to Kafka, I don't have to change anything in here. Whenever something comes, I will run this lambda, which is just printing the string. So that's the consumer side. Let's run the application and see if it's able to connect to RabbitMQ's exchange. RabbitMQ is up on 5672 port, which is exposed in Docker. And let me go back to the application again, my desktop. All right. The application started. And as you can see, it successfully connected to RabbitMQ's exchange. It was attempting to connect to localhost 5672 because I chose RabbitMQ binder, and that's the default. I am bound to the exchange of events. All right, but there's nothing coming to that exchange, so let us fix it. In order to do that, we need to register something on the producing side. So again, we are talking about the functional realm. So in the previous example, we had the consumer of the information, of the string or event, whatever you send. And at the producer side, I need to register a different function. And this time I'm talking about the supplier, because I'm a supplier of information to the channel called output. Why output? Because you might remember that in the properties I specified this channel in here. So I have output channel, and it might be something like this. Hello from supplier. Not very sophisticated, but that's the best I can come up with at 4 a.m. Hello from supplier. All right. So I have a supplier bin, and I have in the different application a consumer bin. So I have two functions registered. They are matched to the specific channels thanks to the names of the bins. So let me run this application, the producing application. I have sync, which is already running, the source application connected to localhost 5672. And as you can see, I'm seeing periodic statements. Interesting. So how come I'm sending information where I just registered a bin? So if you take a closer look in the documentation, you will see that just registering a bin is enough for Spring Cloud Stream to send messages, because there is also a default folder that sends messages every 1 second. Of course, I can change that to cron. I can change that to fixed delay. I can do whatever I want. Most probably, you would like to send those events not periodically like this, with this folder registered under the hood, but maybe you would like to send the information on demand. So to do that, you need to in the new API, you need to, which is, by the way, not that new, but we are doing this class. We have been doing this class for months, and I just forgot to change the demo. The blame is on me. You need to register to auto-wire the stream bridge. And thanks to stream bridge, you can do whatever you want. You can send information to the, as you can see, the channel, and the actual information in the second parameter, so the message. So we can do it on demand. Previously, in the previous API, which is now deprecated, you would do something like this. You would, on the consumer side, you would use an annotation called, if my memory serves me well, stream listener. Yes, it's deprecated. To say, to teach Stream that, you know what, this method should be invoked whenever something comes on a channel called something, like maybe input or output. So that's this parameter. But now there is more functional API. For some people, it might be counterintuitive that just mere registering two different functions gives you possibility to talk periodically every 1 second. That's because we have this polar register that you can change, you can configure, you can disable, or you can just send events on demand. All right, so I'm going to shut it down. System worked.